Hello, welcome to Algebra 1, Lesson 1.9, Take 2. My son had told me that there's so much feedback on the last one, he couldn't watch it, so we're going to try it again. I do not watch the videos after I record them because I don't like the way my recorded voice sounds, so I generally stay away from them. So if anyone ever notices anything wrong with them, you can text me, or if you don't have my number, you can make a comment on the video and I'll try to get it fixed for you. All right, so getting started. Remember, we just went over simplifying radicals, taking a radical, something that was under a radical, and making it down to its smallest radical possible, the smallest irrational number we had. And so that comes in helpful when you have it in the form of an expression. And remember, an expression is a mathematical sentence, an incomplete mathematical sentence, so it doesn't have an equal sign. And sometimes you'll have radicals in different terms. And remember, a term is separated by a plus or a minus. So in order to simplify those expressions, we want to combine it down to the smallest amount of terms possible. So the way that we do that is with radicals is we treat it just like a variable. So if you have, remember, if we have something like 3x minus 2x plus x squared, okay, we want to find the like variables. And when you have variables, that means the letter and the exponent need to be the same. So in this case, we only have two like variables right here. When you have like variables, you write the variable and then you combine the coefficient. So a positive 3 and a negative 2 combine to be a positive 1, which we don't technically need to write because it's implied. Anytime you don't have a number in front of a variable, a positive 1 is going to be implied right there. So I'm just going to leave it as x. And then we would just add this plus x squared here on the end. And that would be, it's kind of in the wrong order. You'd have x squared at the beginning, but you get the idea. You keep the variable exactly the same when they are like variables and add the coefficients. Well, it's the same when you have radical expressions, when you're doing addition or subtraction of like variables. If I had, for example, 3 radical 2 minus 2 radical 2 plus, let's go with radical 3. Okay, well, we need to find the like radicals. Well, radical 2 and radical 2 are like. So I'm just going to write radical 2 here. Nothing is going to change about it. Just like when we had our variables up here with x's, nothing changed. It just became x. And then 3 minus 2 is positive 1. That's an implied number 1, so I don't need to write it, just like up here. And then my radical 3 is not like any other radicals, so I'm just going to write it down here at the bottom, and that's my simplified expression. And so you can see how combining like radicals is just like combining like variables. So in order to combine like radicals, you first have to identify them. So here in this exercise, we're going to identify which radicals match the others, so we would be able to combine them. You have a hint here. You're going to need to simplify to identify your like radicals because these are not in their simplified state. So we don't know which ones are alike and which ones aren't. Well, some of these are. Let's look at number 1. That one's already simplified. I know if something has square root 2, it's in its simplified state. However, square root 27 is not. Square root 27, we can remember, is square root 9 times square root 3. I can take that 9 out of the square root, and that becomes a 3. If I took the square root of 9, it's 3. 3 square root 3 is what square root 27 is. Okay, same thing with radical 45. It is square root 9 times square root 5, which ends up being 3 radical 5. 28 is radical 4 times radical 7. So the 4, I can actually do that. That's a perfect square. So square root of 4 is 2, and then square root of 7. All right, so moving on to the letter side here that we're going to match it with. Square root of 12 is square root, oops, let's write it down here. Square root 4 times square root 3. And we can easily simplify square root 4 down to 2 and then square root 3. This one's already simplified. This one is square root 4 times square root 5, which is 2 square root 5. And 8 is square root 4 times square root 2, which is 2 square root of 2. So now let's match up some of these expressions. 3 square root of 2 is going to match here with D. Let's add it together. 2 square root of 2 plus 3 square root of 2. Now this wasn't a part of the exercise, but we're just going to do it just to make sure we have some extra practice adding these like radicals. So when I have 2 square root of 2 plus 3 square root of 2, all I have to do is write my radical 2 right there on the side, because that's not going to change. And then I add my coefficients. 2 plus 3 is 5. All right, moving on. 3 square root of 3, well, that matches right here with A. So 2 square root of 3, let's see, plus 3 square root of 3 is, my answer is going to have square root of 3 in it. 2 plus 3 is 5. All right, and I see a pattern emerging here. It seems like everything is going to have a 5 in front of it. 2 plus 3 is 5. Everything, the coefficients are 2s and 3s. This one is a radical 5, so it connects right here with this radical 5. 2 radical 5 plus 3 radical 5 is, yep, I was right, 5 radical 5. And the last one, 2 radical 7 connects here with 3 radical 7. So let's add 2 radical 7. Guess what we get? 5 radical 7. So hopefully you were able to see how all of that worked out and matched. Now, so here we have an expression that needs to be simplified, because we can write this in a lot shorter expression than what we have here. So the first thing you need to do when you simplify this is we're going to have to reduce or simplify everything under the exponents so that we can see what they're in their simplified version, so we can combine it. Because right now I don't see anything that I combine. Radical 18, radical 8, radical 24, none of those match. So I know 18 is 9 times 2. 8 is 4 times 2. Oops, can't forget my radical there. And 24 I know is radical 4 times 6, radical 6. All right, and so this helps me because now I can rewrite this expression right here. Negative 3 times, I can take the radical 9 out to be a 3. Square root of 9 is 3. And then I've got my radical 2 at the end. Okay, now my next term here, I've got my plus 3. Plus 3. I can take the radical 4 out of its little house, and square root of 4 is 2. And then I still have the radical 2 right there. And then my last one, there's no coefficient, but it is a minus. So this radical 4 becomes a 2, and radical 6 is going to stay right there. So let's just combine these coefficients. Negative 3 times 3 is negative 9. Radical 2, right? And then 3 times 2 is 6, radical 2. And this is negative 2, radical 6. Well, I can already begin to see I've got here 2 radical 2's. Hopefully y'all can see that as well. So I'm going to go ahead and just write radical 2 right here, because I know that that's not going to change at all. And then I've got a positive 6 and a negative 9. When you have 2 different signs, you need to find the difference. So 9 minus 6 is 3. And then your answer takes on the sign of the number that's the larger value. 9 is larger than 6 and it has a negative sign. So our answer is negative 3. So we're going to put a negative 3 right there. Minus 2 radical 6. And that's our final answer. Make sure you're taking notes. You can always pause and go back if you need to when you're taking your notes. So right now, I do want you to pause. I want you to pause and practice numbers 1 through 4 here, and then unpause it when you're done and we'll go ahead and go over the answers. Welcome back. So the first thing we need to do, I don't see any like radicals here, so I need to figure out how to simplify radical 28. Well, I know that radical 28 is, it's 2 times, let's say I don't know that a 4 goes into that. So let's say it's 2 times something. Well, half of 2 is 1, half of 8 is 4. So it's 2 times 14. Well, I know 14 is 2 times 7. Okay, so now all of this is under my radical sign. This is a prime factorization of 28. So I can match up my 2's to move outside of the radical. So I'm going to have 5 times 2 times radical 7. All right, so here we don't have to do anything with this next one, 2 radical 7. It's already in its simplest version. 14 is just 7 times 2. And there's nothing out of that that I can pair up. There's nothing that I can take the square root of. So it actually is already simplified as well. So now we see that there's 2 like radicals here, the radical 7. So I'm going to go ahead and write radical 7. I know that that's going to remain the same. 5 times 2 is 10. 10 plus 2 is 12. So 12 radical 7 minus radical 14. And that's my final answer for number 1. All right, so moving on to number 2, we've got 3 radical 32. I happen to know that 2 times 16 is 32. And so doing it this way, what I'm going to do is keep my coefficient here, 3. And then I can't find the square root of 2, so I'm going to put in the square root of 16 because I know that is 4. Okay, and then I can't forget my radical 2 here. Okay, and then minus 4 radical 2 is already in its simplest form. So there you go. And I have 2 like radicals, and it's radical 2. So I'm just going to go ahead and put that right there. And then 3 times 4 is 12. Minus 4 is 8. So my final answer is 8 radical 2. Now, 5 radical 80. Okay, I know that 4 goes into 80, and 4 is a perfect square. So I'm going to put a 4 here. And, well, 4 goes into 80. That's going to leave me with 20. Well, that's 4 times 5. So 4 times 4 times 5, plug it in my calculator just to make sure that is 80. So I'm good. So I actually see here a pair that I can move out. I'm going to start with my coefficient first. Always start with your coefficient. And then when I find pairs like this, 2 become 1 and move outside of the house or the radical. So I started to write 2. So my pair of 4s become 1 4. So I'm going to write 4 right here. And my 5 is my lonely only, still in the radical sign, still in the house. And minus 12 radical 5 is already in its simplest form. So now I need to identify the like terms. It's really easy when there's only 2 terms and they're exactly the same. It's easy to identify the like terms. All right, so 5 times 4 is 20, minus 12 is 8 again, 8 radical 5. All right, this one's got some bigger numbers, so you'd think it might be a little harder, but we'll see. It's plenty simple. All we have to do is find the factorization. So 72 is even. I'm going to start by dividing by 2. And when I do 72 divided by 2 in my calculator, I find out the other one is 36. Well, I know 36 is a perfect square. So I'm going to go ahead and write my first term over here with my new information. I start with my coefficient, -3 times the one I can take out of the radical is going to be the square root of 36, and that becomes 6. My 2 is still stuck inside that radical. So these are times symbols, and there's a negative at the beginning. Got to make sure I can read my own handwriting here. That's very important. All right, so 52. All right, well, I'm not sure really what goes into 52 other than 2, so I'm going to start with that. Half of 50 is 25, plus 1 is going to be 26, because 1 is half of 2. I can divide 26 by 2 again. And that's going to give me 1 and 3, that's 13. Okay, so the prime factorization of 2 is 2 times 2 times 13. And when I plug that into my calculator, I make sure that I did it correctly. I didn't leave anything out. I got 52. So that means I've got a pair right here that I can move out. So I always start with my coefficient, positive 6 plus 6. My pair of 2's here will get married. They'll join in unity and become 1. And they're going to move outside of the radical. So 6 times 2. And then my lonely only number 13 is going to stay right there inside the radical. All right. Last one here, 128. Okay. Now I'm just going to start with 2. Okay. Half of 100. Let's do this off to the side. Half of 100 is 50. Half of 20 is 10. Half of 8 is 4. So that is 64. Okay. So that's 2. Well, I can divide 64 again by 2. Okay, so half of 60 is 30, half of 4 is 2. I can divide that by 2 again. Let's see, 2. That's going to be 16 times 16, but I don't want to stop there because I've done so many factorizations. I don't want to put a 16 here. I want to get all the way down. I want to find pairs. So I know 16 is 4 times 4. So I'm just going to go ahead and instead of putting 16 there, put 4 times 4. That way I can find some pairs. Because I don't like mixing my methods within the same term. If I'm doing paired, the paired way of finding how to simplify a radical, I don't like combining it with the perfect root way within a single term. As you can see, I do combine ways within an expression, but I usually do not do that within a term. So that's why I didn't feel comfortable putting 16 here. I wanted to put 4 times 4. Okay. So now to write this, I'm going to start first with what? Yes, my coefficient, which was -7 in this case. And then I'm going to find my unions. I've got a union of 2's that are going to become a single 2. That's a times sign. And then I've got a union of 4's that are going to become a single 4. And I've got this one number 2 left, lonely only, going to stay right there inside the house or the radical. All right, now let's look at this. -3 times a positive 6 is going to be -18. And then 6 times 2 is 12. Those are both positive. -7 times 2 is -14 times 4. Oh, where are my notes? Let me make sure I'm getting this right. This is number 4. 1, 2, 3, 4. I did my notes wrong, but 7 times 2 times 4 is going to be 7 times 8, which is -56. Okay. Right. So sorry about that. I got myself a little off focus there. Let me go ahead and readjust myself, make sure. What I'm doing is I'm adding these up. I've multiplied the coefficients here just to make it easier for me. Now I need to identify what radicals are like. So I've got radical 2 here and radical 2. So I'm going to start by writing radical 2. I've got -18 here and -56. They're like terms or the same sign, so I'm going to combine. If I have the same sign, I combine. 6 and 8 make 14, 5, 6, and 7 make 74. So I've got 74 radical 2. And then let's go ahead and cross those out so I know I've used them. So I've got this one left, which is going to be a positive 12 radical 13. So I've got all my answers here in black for us so we can easily identify what they are. Go ahead and hopefully you all got the same 4 answers as me. You have it all written in your notes. If not, pause and make sure you get it done now. All right, so another operation you can do with radicals is multiplication. So when you have multiplication, it goes back to our original product rule that we learned when we were learning simplification of radicals. So 2 times 6 is the same thing as a radical 2 times 6, or radical 12. So anytime you see multiplication, we can just combine it all. And so let's look at that in an expression real quick. Here we have an expression of 2 times 7x times 3 times, this is radical 7x times radical 14x squared. So I'm going to rearrange this because with multiplication, you know that 2 times 3 times 4 is the same thing as 4 times 3 times 2 is the same thing as 4 times 2 times 3, etc., and so on. And so order is not important when we're multiplying. As far as it has to be done in a specific order. Order is important in the sense that we need to put it in the order that makes it easier for us. So we're going to start with the coefficients. So I'm going to put the first coefficient here, 2 times 3. That's this other coefficient. And then I'm going to move on to the radicals of the numbers. So times radical 7. Okay, the next radical with a number is radical 14. And now I'm going to move on to the radicals that are variables, times radical x times radical x squared. Okay, now what I want to do is I want to combine this information. Okay, so the first thing I'm going to combine here is the 2 and the 3, and that makes a 6. All right, the next thing I want to combine is I want to combine the numbers under a single roof, under a single radical, but I'm not just going to multiply them. I'm going to kind of factor them out a little bit. So the 7 just went straight down to right there, but the 14 I'm going to break out into times 7 and 2. 7 times 2 is 14. Okay, so hopefully you can see where I'm headed with this. And then my variables, I'm going to put here, I've got my x, and then my x squared means I have times x and times x. All right, so I know that you are a brilliant mathematician, and so you've already gone ahead and noticed what I'm doing here. I'm pairing up some things in this factorization to be able to move them outside of the radical. And so I've got my 6 and then my union of 7s when they become 1 and move out of the radical are going to be right there. Then my x's are unified and became 1. So I'm going to move them outside of the radical as well. And then I'm going to write all the things that are left in the radical, which is simply this number 2 and this x. So I'm going to put those right here. The only thing left for me to do is to multiply all the things out here in my coefficient spot. 6 times 7 times x. 42x, and then radical 2x. And that is multiplication of radicals. You just rearrange stuff to make it easier for you so that you can go ahead and combine it and then simplify it. And here are, if my handwriting wasn't that great, this is good for notes. It has written explanations as well as all the numbers for you. And it's better than my handwriting. All right, so simplifying square roots. One thing you need to know when we simplify square roots is that we cannot have a radical in the denominator. It's just not allowed. So what we have to do is find a way to get rid of it when that happens, because it still happens. So we just have to find a workaround, right? And so the workaround that we have in math is to multiply by the number 1. If you take this and you multiply by the number 1, you're still going to end up with 2 over square root of 3, right? It's still the same thing. So what's something we can write as a number 1 that's a little more complicated that might help us get that radical out of the denominator? Well, when we multiply a radical 3 times a radical 3, what are we going to get? Well, that 2 will become 1, a single 3, no radical sign. So in order to make this a number 1, we also have to put a radical 3 on the top. So 2 times radical 3 is 2 radical 3. So the proper way to write 2 radical 3 is going to be as 2 radical 3 over 3. Okay, so this is the answer that has been rationalized. This is called rationalizing the denominator. Okay, so here we have radical 4 over radical 5. And remember, we can write this like this. It's the same exact problem, just a little easier to work with. And we're going to multiply it by 5 over radical 5 over radical 5. Okay, and in this case, on the bottom, a pair of 5s, 2 will become 1 and move out of the house, becomes a single 5. 4 times 5. Well, instead of just multiplying those and then having to simplify them again, we already have right here a perfect square of square root 4. So I'm going to go ahead and take that out. Square root 4 became 2, and then radical 5. So 2 radical 5 over 5 is our rationalized answer. All right, so here's some practice for you. I want you to go ahead and, well, actually, let's do the first one together before I have you pause, because I want to show you something. You think about it other times that you multiply fractions, but you may not have thought about it when rationalizing the denominator. There's cross cancellation that you can do, and it's really going to be it makes the problem so much easier. So if we think of this as square root of 4 over square root of 9 times 18 is going to be square root of 9 times square root of 2 over square root of 4. Now we can cross cancel. Square root of 4 times square root of 4 gets, those get canceled out because there's one on the top and one on the bottom. Square root of 9 and square root of 9 get canceled out because there's one on the top and one on the bottom. So what does that leave us? That leaves us the square root of 2 over 1. And remember, we don't need to write a denominator of 1. So that just leaves us with the square root of 2. Go ahead and pause the video, and I want you to practice the rest of these on your own, and then come back, unpause the video, and we'll go over them. Welcome back. We're going to go ahead and begin our next one here, square root of 8 over square root of 11, and it says times square root of 2 times square root of 11, because that's 22, right, over the square root of 2 times the square root of 8. Now let's find what we can cancel. Cancel, 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 cancel. I think, did I not multiply these correctly? Let's see. 832 is 4 times 8, not 2 times 8. I don't know what I was thinking there. Let me go ahead and erase this and redo it. I'm sorry about that, guys, but it's always good when you notice that there's a problem. You want to definitely look at that. All right, so there we go. And there we go. So that leaves square root of 2 over square root of 4, but don't worry, I can still cancel that a little bit more because square root of 4 is square root of 2 times square root of 2. Cancel those. That's going to equal 1. Now, on this top one, we didn't have to put 1 in the denominator, but you always need to have something in the numerator. So you have to put a 1 there over square root of 2. And now we have to rationalize the denominator, and it becomes square root of 2 over 2 as our final answer. All right, so with this one, I'm actually going to cancel some of this before we move on, because 20 is square root of 4 times square root of 5 over 15 is square root of 3 times square root of 5. Okay, so you can see here, I can just get rid of these square roots of 5s. And then instead of saying equals, what I'm going to do is go ahead and rationalize it right here. So times square root of 3 over square root of 3. And that means my denominator is 3. And my numerator is 3 times square root of 4 times square root of 3 is, well, let's look at that. 4 square root of 4. I can actually go ahead and complete that. Square root of 4 is 2 times square root of 3. Now, is there anything else that we can simplify in this problem? Well, there is. We can get rid of 3 over 3. So my final answer is 2 square root of 3. All right, here we go. Radical 7 over radical 3 times radical 3 over 28 is radical 7 times radical 4. So let's go ahead and simplify these. Get rid of cross cancel, rather, I think is the proper term. Square root of 3 and square root of 3 cancel out. Square root of 7 and square root of 7 cancel out. And that's going to leave us with 1 over radical 4, which is 1 over 2, because radical 4 square root of 4 is 2. So it equals 1/2. And there you have it. All right, last one, radical 2 over radical 5. Go ahead and rationalize this denominator here by multiplying by 1. And we're going to get 5 on the bottom. And 2 radical 5, neither of those can be simplified, so it's going to be radical 10 over 5. Now, I mentioned, I think in a previous video, about something called an imaginary number that we don't generally get to too much in Algebra 1, but I do want to introduce it to you. The imaginary number is the number that is the negative square root. So when you find an answer and it says you have something like the answer is the square root of -4, you can say, oh, there's no real answers. And that's true. There's no real answers, but we have an imaginary answer, right? So the square root, let's say, of -5 is equal to the square root of 5 times I. Now, I is the square root of -1. So that works right here. Here's another one. Let's think of the square root of -12. And again, if you don't want to know this right now, you don't have to. This is just a hint of how fun imaginary numbers are and easy. They're nothing to be afraid of. So 12 we know is 4 times 3, right? So 12, the radical 12 equals radical 4 times radical 3, which is equal to 2 radical 3. Well, if it's a -12, then you have 2i radical 3. That's simple. If you break anything down to, let's say we had the square root of -4, that'd be equal to 2i. Okay, just a little taste of some stuff to come. Y'all have fun, and we'll see you next lesson.